Good morning. Morning, everyone. Just wait maybe 10 or 15 seconds to just begin. Great. I hope everyone's having a nice morning, afternoon, or evening, depending on where you are. Yeah, and welcome to the second part of our webinar series, AI Architecture, Planning the Functional Logic. I'm Michael Lawler, and over the next hour, we're going to dive into how to take a prototype to production with AI. We'll take what we made last week in the rapid prototyping webinar and translate that into real AI architecture with AI primitives that enable our developers to work faster. Today isn't about some fancy AI agent solutions or custom workflows with building our own SDKs. Today is about what we have readily available in our work to improve our current workflows with out-of-the-box coding agents like Cloud Code, Copilot, and so on. This involves today thinking about what has to be done before any new code gets written. And it's about the decisions and constraints. It's about making sure that when engineers sit down to build with AI to deliver products quickly, that they have the tools at their disposal to do that and to do it with the maximum quality. That's what we'll get into in the next 45, 50 minutes or so. Okay, so I want to frame it a bit. This is the second part of a three-part series we're running. Last week in webinar 1, Martin took you through rapid AI prototyping from concept to functional product. So we went from how to take an idea, a blank page, to something functional. I'll show that in just a minute. Something you could test with real users. It's about speed, validation, and using AI tools, something like GitHub Spark or Figma Make. Today's webinar, we're looking at planning the functional logic, quote unquote. We're taking what we worked with in the prototype and asking how do we actually build this responsibly? What decisions do we need to lock in already for our agents? And what constraints do we need to respect? And from those inputs, we make AI primitives. What AI primitives do we need? What are AI primitives? We'll learn in a second. And then in 2 weeks, or next week actually at this point, it's about taking it to production. Our CTO, Florian Asmus, will take where we are and what Martin built in last week's and build the actual product using the primitives and agents that we built today. Each one builds on the last. And the main thought we have is that we can't expect developers to work without knowing their environment and their context. And AI agents and the tools they use are no different. So we try to equip our agents with the correct tools to be more independent and thus enable our developers to be better with AI. And this is the, why listen to me slide. I'm Michael Lawler. I'm an AI software engineer at Prodyna. I've spent the last 3 years at Prodyna. I've worked across full stack from front-end frameworks, development to iOS apps, Java, Spring microservices, and lately more with infrastructure and Terraform. In the last 18 months to 2 years, AI agents have become, let's say, a bigger issue. And we have to ask ourselves, how can we build the better products that aren't just prototypes with AI so that we can reap the benefits of building quickly, but also avoid the downfalls that are so commonly associated with building with AI tools. I've been through the cycle multiple times of, hey, I have a product, I want to build it quickly. Look, stakeholder, I've built it. And then we get to the decision of, can we use it? And it's, this quote unquote slop comes out. And I'm here to share today that what we've learned in that time as Prodyna, as me personally, the mistakes we made. And that's not to say that when I was preparing this presentation, I didn't also make mistakes. I do, and I still do, and we all do, and they're very, so what makes these presentations interesting, the unknown fact of it. So any questions during the session, please feel free to write them in the chat. I have it here next to me. If you see me looking in this direction, you'll see me looking at the chat. I'll do my best to answer them if they're in the flow of the presentation. And if not, I'll address them at the end. I should have some minutes at the end. So great. I'll give you an overview so we don't get lost along the way. I'm being transparent. This is a lot of information I'm going to try fit in. I'm going to try give one concrete example where we can show the end-to-end primitive building. But yeah, first we're going to recap the first session. This is going to involve everything we do today is going to have some impact from the last session. So this will come from understanding that problem. If you weren't there, this will bring you up to speed. And if you were, then think of it as grounding into the same context so everyone understands. Yeah, then we'll dive into some handover stakeholder documents and requirements. For the presentation, we use the Greenfield solution as to make it easier for us in the 1 hour we have. But we still need decisions regarding programming languages and architectural decisions and what testing mechanisms we use to narrow the scope for AI. And these are very much synthetic. But in a brownfield project, we would derive these from the existing code base, and we would likely get better outcomes than something we could generate just as a text document. For the sake of the webinar, then I will use some form of simulated stakeholder input. Then, as I said, we will need to go into AI primitives. So, what are they? What makes them? What are they made of? I want to give you an overview of what they are and how useful they are and how we build them together. And this should hopefully help you to understand where to use each of them and when. Exactly. And in the end, we'll show an empty code base. Effectively, it's sitting behind the current presentation you're seeing. And we'll combine all of the primitives with the briefing, with the handover documents, and we'll try to figure out how we connect them with the example of using GitHub Copilot for today. But the lessons we will learn throughout the next 40 minutes, 50 minutes will be applicable to most, if not all, coding agents and AI setups in any form of IDE. As I said, there's a lot. The section on primitives itself is very information dense, but also very worthwhile in my opinion. So yeah, let me know if I need to slow down. I have a tendency to speak fast. So please, if something's not clear, write it in the chat. I'm more than happy to explain something twice at the cost of showing you an example, which I could also show you in shorter time. Great. So the use case. In the first session, we introduced company Clave product files as a product finder solution. At its core, it's just a search problem. So I frame it like the client comes to us, this made up client in this scenario, because their current process of searching is too slow. Users either browse through hundreds of documents, catalog items, they wait for engineering support to point them to the solution, and they're not great experiences. The company also doesn't have too much budget to invest at the moment, and this is not a crucial aspect of their business. It's more of a quality of life improvement, as very small amount of their sales are generated from the web. So our job was then clear. We have a limited budget. We need to move fast. We need to take the problem and turn it into a prototype. We need to test the prototype to create a better search product experience. And the goal is there to build something that's intuitive and dynamic, but still core search. Nothing fancy, just a really simple use case. So what we already have made in the last session is a Figma Make prototype. We can give this to the stakeholders to discuss, validate, and improve before we invest into production. So I'm just going to open this here. Give me 1 second. Okay. Let me pull this in here. This is the prototype, what it looks like. I'm not going to spend too long here. Everyone knows what a search looks like. We have filtering capabilities without end, but you can see that some complexity in products like this and adhesive products are very specific. So for UV resistance or whatever. In the last session, actually, the AI suggested they build a compare feature, which Martin builds ad hoc on the run, which is super impressive with Figma Make. To search for products, and I mean, the search works, it uses a specific backend and so on. But the idea here is that our team can quickly get to some form of prototype to assess the feasibility of such a project, and if the stakeholders who will use it find it more valuable than the current solution. Exactly. So we have products and compare, and we also have contact forms and so on. The use case is clear. Okay. So throughout the session, when we talk about AI architecture, we need to remember this context. We're taking a quote unquote real client problem, turning it into a working prototype quickly with some form of generative AI. So Figma Make in this case. And now we want to build the building blocks on how to bring that prototype into production in a structured way, following our rules, while leveraging AI into the production phase, so that we don't just have this quick upfront software development lifecycle part, but we want to introduce AI throughout the software development lifecycle. And we want to maintain quality throughout those stages, but we also, of course, want to increase the speed and try to realize the benefits of using AI. Great. So where do we start? So there's something everyone's learned along the way in any project they've done, is that no decisions are made in a vacuum. It's greenfield projects, but you still have stakeholders, and AI agents, yeah, they're flexible, but they still need rules. And when we sit down to design these infrastructure, these primitives, we don't get to start from a blank page. Like I mentioned, we have constraints, we have opinions, we have a lot of stakeholders. For example, Martin spent a lot of time designing this UX. He's made decisions about how it will, how it looks, how it flows, how the information gets presented, what filters do we use? What's the UX pattern? What's the accessibility, for example? When developers then will leverage AI agents to build this context may be missing. That also includes when we talk to our CTO, who may make architectural guidelines and infrastructure preferences, and they're not really suggestions, they're constraints we need to put somewhere so that the agents can also understand them. The product team may require security needs, their quality assurance and compliance teams, again, accessibility, maybe audit requirements. And we created these documents to simulate that environment of how we would obtain this information. So these represent decisions that were made at a higher level. And our job here is not to ignore them or to work around them or to implicitly understand them as engineers do. It's to integrate them into a way in such that AI agents can understand them. And so we need to understand what documents matter. And so here I simulate, like I mentioned, a brown field. Every project has some constraints we needed to put them in. We will show you some examples when I get to the code base. I will walk through what, for example, a feature document will look like, or what would input from a stakeholder look like that we could prepare and we could move between projects. But the message here is pretty simple throughout. Before we use agents for anything, or most of us, we probably use now for everything, they need to read the documents to understand what we're telling them to do. And so we need to synthesize these decisions, into formats in which agents can understand, search, and choose correctly when to use the right one. So it's not just about having the abundance of information available, because that will thus lead to context crowding or some form of bad decision making from the agent. We need to have them in such a way where they're concise, documented, bullet points, numbered, whatever we want to call it, whatever way we prepare them. And yes, one of the selling points of building with AI is that it's more flexible. You don't have to think about this, but this is not like some overhead we don't consider. This is simulating a brownfield project in a company in which has decisions already made. They're the guardrails for your AI. They'll stop you from doing this thing where, oh, look how pretty the POC I just showed you is. And that sits in some local host 3000 or 5173 port for your engineers to look at and say, oh, wow, what could have been? We need to find a way to get that to production with the requirements we mentioned, like accessibility and like architectural decisions. And this is, in our experience, what separates the prototype to the production system, and how you get there with AI, because this middle step then frames every decision we will make afterwards. Okay. Yeah, 1 second. Before my voice goes. Primitives, this is I promise, the heftiest section, but you can read this, you can search it afterwards. I'm going to give a broad overview, a couple of examples. But they're really important to understand, because they're the building blocks of what agents do effectively. And so before we can actually talk about agents, it helps to understand what we can add to them to make them more useful. So we call them primitives, as they're the fundamental building blocks. So like the Lego pieces you clip together. There's some really nice diagrams on this if you search it. They combine them to create the functioning agent. It solves a specific problem for how do I tell an agent what to do? What does that look like? So how does it interact with the real world? Hint, MCP server. How does it discover what capabilities it has? And how do we make sure it's reliable? Always repeating the same patterns, always following our style. So we don't have some senior engineer who has something against software engineer / AI and just keeps rejecting the pull requests made by any AI driven development. And the one thing that's completely clear is that this preparation is what makes them usable. And the best model is being proven to be very good, but a model on its own is not the be all and end all. There's a reason why people say Cloud Code is better than Gemini CLI. This is the harness they use and the things they build around it matters to how well the models and the agents act. So what is the first set? Okay, we've probably all heard these words before. Prompts, instructions, they define the agent behavior. They're reusable task templates. They provide flexibility and reduce redundant workload. So instead of writing a new prompt every time, so every task generate API endpoint, you can create a template which composes across the domains you will use. For example, you given these product specs and given this user constraint, identify X. Instructions, on the other hand, are guardrails. They're specific to the product. So what you will see in a minute is that we will have a monorepo, we have a backend, a front end, infrastructure, and then an open API definition. They all have different rules. We need to be able to make sure that they're following them correctly. And so instructions embed the domain rules, the business logic. They ensure that we have consistent operations within the boundaries of that file or folder in this case. For example, front end uses React, TypeScript, Playwright, whatever you want to think. We use Tailwind for styling. Like these are the things you put in there so that it's the training bias, which is inherently built into models and therefore agents, doesn't come through. Together, then the prompts give you the flexibility and the instructions ensure that the product is made in the right way. Again, probably tools, yeah, okay, implicitly, but MCP was probably the buzzword of 2025. Let me explain we start here from building everyone up. Tools then bridge the real world to an agent. So they connect to APIs, they connect to external services, they let them read code in the IDE. Yes, like it's not implicit. They build a tool that gives you access to your IDE to allow it to read code, read files or whatever. The terminal is a tool. The problem is that if you have to write a tool for every integration, this will quickly become a customization nightmare. Imagine you have a SharePoint and a GitHub, and then you all have separate authentication and response formats, and you have to then teach an AI through text how to format that. And that's effectively what MCP saw, so Model Context Protocol. It's just a standardized protocol for tool integration that makes the composition predictable. So your agent doesn't need to know specific API details. It says, hey, I need to book an appointment. It looks in its tools and says, okay, a book appointment tool. That looks like right to me. It has a description. And then the MCP takes what the input is from the agent, translates it and calls the API. This handles the response and returns then just text. So we abstract this logic behind the MCP. MCP are consumed as tools. So when you add one, which we will in some minutes, you will see that they come up as tools. And I have a lot of them installed, and I'll show you how to filter them and so on, so that you don't get, context rot is the buzzword. Exactly. And now, even for me, very new topics, spending quite a lot of time now trying to figure out where to best use these, how to integrate them correctly into the system. And the main thing is these help agents they give agents context. So skills are like packaged capabilities. They encapsulate the abilities for repeated engineering tasks, similar to instructions, but not quite the same. Instead of hard coding everything into a massive prompt, it is progressive discovery. For example, something like Anthropic's front-end design skill. I don't know if you've heard of this, but this is effectively Anthropic iterating. So Anthropic are the company who make cloud code and so on. They're iterating with the stakeholders, front-end designer, front-end engineers, designers, and so on. How does AI look less AI generated? And what they done is they took all that information, they put it into a skill, and they describe when to use this skill. And from this, the AI will say, oh, okay, I have a skill. Like, let me see, I'm doing front-end design. I reference a skill. What does the skill say? And it has a set of rules. So distinct patterns, how to create certain typographies, when to use certain colors, how to avoid generic layouts, and so on. This is things encapsulated in skills. There's tons of other ones, but this is probably the most known one from the very beginning. And now people are really like betting on skills. And the second one, also quite new, is hooks. They're like event integration. So they're like, think of hooks like a lifecycle integration, or like a middleware that sits between the agent and the tool it's calling, for example, or agent and event. They don't really teach anything. They listen for specific moments in a workflow, and then they use a trigger defined in a JSON and a shell script to run an action. And because, or a bash script or whatever, it's also irrelevant. This triggers then background functionality. So you can imagine something like, after every tool call, log exactly what tool that agent used. Because in the end, we want to see what mistakes were made, or what the agent done wrong, or what tools it used, what API did it call, and so on. Especially if we're running something like autopilot mode, which is just do whatever you want. And then a hook basically sits between when the agent does something, it listens to that event listener, and then it says, hey, 1 sec, let me log what you just done here. You can continue with your work. But that can also be things like write documentation. When an agent stops responding, check what it done, spawn a new agent of yourself, review what was changed, and if needed, write documentation. And if you go further with this, you can imagine this inception we spawn by being able to use hooks and build agents that way. Okay, I told you that was the most information dense part. But so yeah, I hope this gives a good overview. And now we can actually understand that how it all connects together. So the agent sits at the center. A system prompt in a coding agents, so GitHub Copilot or so on, they have their own. You can turn it off in settings, but they have their own. This is not controlled by us. This is also built-in tools and the connected model. We can choose what model we use, but they're connected to a model. And the tools often they have built in are specific to IDE. We have the instructions, like I explained, the tools, the hooks, and the skills, they all connect together. And then the prompts is dotted because maybe we use them, maybe we don't. Then the agent takes all of this input, applies all of them, reasons about what to do, calls the tool if necessary, executes the relevant skills if needed. And then at the end, the hooks control the side effects. So log, for example. An example I've mentioned 100 times of what is an agent is technically GitHub Copilot, Cloud Code, but also Copilot 365, Cloud Cowork, name them. They're all agents. They're the same fundamental thing, this build, but different contexts and capabilities. And that's why knowing when to use these things and what they are can help you to build more stable infrastructure. And if those things aren't included, if they can't interact with the real world, then it's more towards a chatbot. It's a, hey, like, what's the weather today doesn't work without a tool, right? I mean, you can't do it, but you could ask about the history of whatever. I mean, that's built into the training data. Exactly. So the rest of this webinar now is going to jump in to the VS Code. If anyone has done any presentations with generative AI as the focus point of them, they will know that what comes out is mostly subjective to depending on what mood the model you're calling is in. Not really. But so I'm going to go through one concrete example to show you how you would build a case with some with some prompts I've already prepared. And that way then we could see basically how we would connect them, how we would build them, what we need. And then after that, I have some other prompts prepared where I'm going to actually see how we can speed up that process, simulating that brownfield environment we're using. I'll maybe stop for a minute here to like ask questions, because that's like a heavy theory part, and I also need some water. Okay. No questions. Great. Okay, let's switch to the IDE. Okay. So I'll give you a quick overview of what we're doing here. The Worries in VS Code, this is semi-applicable to all IDEs. For building AI workflows, for building AI infrastructure, AI primitives, VS Code tends to be the one that works best for an IDE, as it sits in the same building as the GitHub Copilot team, and the features tend to be pretty on par with each other. And we're also using GitHub Copilot as a driver for today. That means that a lot of our examples will be in the .github folder. I'm 99% sure, or I'm 100% sure this is all supported for cloud and more. For other providers, the concepts we cover should be the same. The folder structure might look different. The nomenclature might be different, but in the end, the function of what we'll do is effectively the same. Great. So some hints is we have an MCP JSON, we have some settings. This is to turning on certain rules. We have a backend, a front end, infrastructure, OpenAI, OpenAPI. They're empty. So I am not writing any code today. So if you're here to watch me throw together some code, or maybe the name you were like infrastructure, this is actually all next week. So for today, these are the prompts I mentioned. I generated some generic instructions for how you would go about recreating from this, like I mentioned, brownfield approach, the primitives that are needed to implement that. And that gives you kind of this first spring into what we need. We have the starting docs, which are the inputs, so accessibility guidelines, the handover from dev, which is like a product requirement document that we got from Martin from last week. This describes feature functionality. Yeah, some ASCII wireframes, etc. That's the same for the 5 features or 6 features we'll have. And then these are the stakeholder documents I was talking about. So we have some core decisions. We've simulated that they're from some architects, some platform engineers, some managers. We say that we have a monorepo structure that will use Spring Boot, Java, and Maven. There'll be APIs. And then imagine a scenario where, okay, we know this, we go meet with the teams, we meet with the teams, we have all this information. I would encourage that any project who is, yes, of course. I saw the red dot. Okay or bigger? I wait for the chat at this point. Okay, we'll do it this way. Even better. Good. Okay, perfect. Thanks for telling me, because honestly, I would have done the rest of the presentation basically being able to, no problem. What good is it if you can't read it? So I would have just been talking. Thanks for telling me. Yeah, so the front-end application then defines, as I said, I would encourage that all teams generate some form of document like this, where we can say, hey, okay, what are the core rules we make per stack? And okay, we're doing a monorepo here because we want to do as close as we can to a production project, and we want to have it so we don't have to keep switching windows or messing with the workspace. each thing is encapsulated to, if I'm only a front-end engineer, you could just do the front-end part. If I'm only an infrastructure engineer, I can only do the infrastructure part. But these documents help be the source of truth, and also, in my opinion, don't hurt anybody, and probably should or do exist already in organizations. I hope. And so it's a matter of synthesizing them in ways that are digestible to agents. So for the backend rules, things like card validation or the name of the packages and so on, the structure we would like to use, defined again by our backend engineers, we want them to follow it. Okay, so they're the documents in which we've created. So you can see the primitives in which we have created are here. I've created some already hooks. These are for the end. I'll show you. Because hooks are in the end shell scripts, I won't create any in the live demo. Verifying them will be, not great, let's say it that way. But for instructions, we have none. For prompts, I have a template and I have 2 already. So for example, this is something we can take from another project. You can imagine that it's just an instruction about how to do a security audit. We have how to scaffold a Terraform module based on our things. We have one skill, which is unit test generation. And if you're looking at what things exist, you can probably see the example I'm going to do by using the IDE. And then we have the Copilot instructions, which for anyone familiar, Copilot, and not familiar to agent development, but not Copilot, Copilot instructions is similar to the agents MD or the cloud MD, which is the general rules of how to instruct your agents. So great. For now, we start with the instructions. So we want to create an instructions file. I'm going to use Command-Shift-P. I'm going to do instructions, and I'm going to go generate agent instructions or new instructions file. And you can see here's the options. The fact that it's not standard is quite an interesting topic, considering there's 3 or 4 providers, but you can see where we can leave them. We can see that here, and we want to call it backend, let's say. So we're focusing on the backend here. We have a description and so on. Now, for the sake of our sanity, I'm not going to type everything. We can do it like this, and I'll explain it step by step. So the first thing that's important is that we have a name we can call it by. We give a decent description, but we have this apply to field, which in a monorepo like we're using is super important. One, because we will use YAML files to define our open API, and we don't want to have random Java instructions being used by our agents when developing open API specs. And yes, and so for there, then we include this, and I'm going to paste in a decent-ish example. Again, one thing I probably should have mentioned, and I will before, but I will say probably now until the end, is that these are living documents, right? I mean, in preparation for a webinar like this, we spend some hours imagining a scenario in which could be possible to build such a product, but that's nothing compared to sitting down with your teams at the end, reviewing the documents you've created like you would in any agile flow, and then being like, hey, actually, our agents this sprint were overfitted. But you can see what an instructions file would look like here. So it says that it's product-specific layer for a generic backend agent. These overrider extend the default where CLEB architecture decisions are domain context required. From this document, I generated them from the backend rules. I generated them from the handover. I generated them from the design inputs where applicable. You can see in my prompts that this is the prompt I would use in some case to create a document like this. So the fields are pretty standard for what we want to, the decision matrix in which agents have to use to where they can make better decisions. So you can see we have the core domain concepts, which we've gotten directly from a feature, and we have how the filter logic is currently built in the POC or the prototype that Martin built. We have some architecture decisions, again, for this agent that's relevant to know where they're being built. We have the database in which will be used. Again, this was a piece of information we got from the stakeholders. We have a package structure, again, explaining what, where, how, why, the resources in which will be used, our testing for our unit tests and integration tests. We want to make sure that the contract aligns with the API. We're going to be using OpenAPI 3.1 specification, our data architecture, and then we want to talk about security. Again, specific to us, this specific project, we want to have observability, and the testing and configuration profiles and the build and deploy. And so you can imagine here that these are very, like, for anyone who's built Java applications, this seems like, oh, I don't want to write all this, and either do I. And that's why generating the prompts in which look into your current solution, whether it be starting docs or like a brownfield approach where you already have an existing solution, you can create a document or a prompt like this, which, yeah, the persona prompt where you're a senior software architect, you want to generate the coding instructions, you blah, blah, blah. And then you tailor this to your specific use case. So now we have our instructions file. We're like, okay, what comes next? It's like, okay, we want to do a specific prompt. So we have our prompt in here where we want to go into the create unit test prompts. And this is where we first get into tools. So tooling is important here. I can show you my tools. I have many different projects. They're across super different stacks, and I have MCP installed on my local instance. MCPs installed on my user JSON for my VS Code and not just on the project, which means that I get a lot of context rot if I don't do this. For example, I have a Foundry project, or I have Figma or Perplexity or Postgres, but also different things like Copilot or Jupyter notebooks and a different Postgres, which because I have one locally and one in my user. And the tool section, which is also applicable to the agents, they also take a tools here, exactly the same way. You can configure which tools are available for this specific unit test. And so I can show you now what like a prompt would look like. And so we could generate a prompt. It looks something like this. This is accessible via create unit tests. And then we would give information. And what I've written here is ask for confirmation before testing multiple files. If the user does not specify a target, use the search changes tool to identify modified things. If you look at this, this is the git diff. The execution then explains how to do it and then what it returns and so on. This is like super simple. And in the end, actually, we'll come back to it, but another little teaser is skills reference. And then we're going to use unit test generation. And like I mentioned, skills are encapsulated logic for what we will do. And so where do we move to next? Move to the skills MD, which is again, just another document, just another markdown, and just as tedious to build. But once you build them, they're there, and you can offload it with just this prompt to generate unit tests for the current div. Now you can do this upfront where you provide the information, you do test-driven development. Hey, I'm going to build this, here are my test cases, you write your ticket, and then you let the agent write it. But we're going to do it the other way. We're going to imagine the scenario where, hey, we're building code and now we want to write our unit tests and so on. And so for the unit test generation skill, you can see that the purpose is to create unit tests, application logic. It talks about the capabilities. It talks about the rules. It talks about the output format. And then a checklist, which is important for verifying the unit of work in which the agent has done. Things which to avoid. And again, this is a living document. If I run a unit test and something goes wrong, I add another. And this is what you review at the end of your cycle. When you deliver your first feature or your first domain, you should review this document, seeing if anything was a little bit overfitted or underfitted, or you need more examples and so on. And the skill is now encapsulated. So every time we run create unit tests, the prompt, it will reference the unit test generation for the given git diff, or wait for whatever you say to generate tests for. I mean, we've encapsulated now into this tests, and the thing is, who runs it? And like we said, this diagram of we have skills, and we have instructions, and we have prompts, and we have tools, and so on. But we need the binding factor, which is the agent. For the sake of arguments here, I would not do this normally. I would really plan my tools. read, again, is you can use a browser, you can use edit, you can create files, you can use read, and so on. Planning your tools, what they're able to be used, will stop them overreaching their abilities and keep it in scope. The less tools that it has, the less decisions that it can make, the more likely it is to stay on point for the quote unquote mission. There's also, again, and this what I'm about to paste, another teaser. Again, maybe I should have showed the create agent is also here in the command bar, the same as the skill is here, and you can also generate one by explaining it. These are all available in the bar VS Code. Great. In the agent, so now we have our instructions, we have our skills, we have the prompt that we will use to call it. Prompt can also reference the agent in which we use. For example, if you see here, it's actually using this agent we just put in to run that in here. So if we run this, it will use the agent. We specify the mission, what its job is. We want to shrink that scope of what it's trying to do as much as possible. What we tell it not to do makes more sense. Again, living list. If it starts acting up, it is just a bullet point. Sometimes over specifying things to do is less good than just adding things not to do, as the agent itself is pretty capable. How to make decisions, what priorities we have, again, derived from the, in this case, back-end, front-end, or skills instructions. The test level guidance, how to do it, what are you testing in each phase, end-to-end, the output expectations, the constraints. And as I built this for a full use case, which I can show at the end, you can see that we will have more than one skill applicable here. It's like security hardening or whatever. And you include them at the end, and the agent, through its harness, understands what skills are, will pull them in dynamically when needed, and it will use these skills, these encapsulated packages of work to deliver better solutions. Okay. Now, one thing I can show you in the agent, that let's say it's a testing agent, but we could also build a backend agent. And the backend agent, in my workflow, I wanted to have some access to our Postgres. I wanted to be able to read the records from the database. Now, I only wanted to be able to read them. I don't want it to be able to write them, and so on. And you can see here that I've connected this through query and plan and get and describe and connect and bulk load and so on. But this is not a tool that's out of the box. This is an MCP. So to configure the MCP for the tools in which you will use, it's in this file. Again, same file basically for everything. Most IDEs, most TUIs, terminal user interfaces. And I have multiple here. For example, ESLint. So after it's done, it can lint the file, check it, fix the errors. That can be a hook. When done, run ESLint. Playwright for testing the front end and so on. Terraform, NPX for Azure's MCP and for the Postgres. And so this will ask for an input for the connection string. When I started, I give the connection string, it saves in the background, and then I can access my Postgres TP. Setting up the Figma then is the same for me connecting. When we look at the front end design, we can connect back to what that design looked like and actually pull that information in and let the agent design our front end code with direct access. Similarly, we can use Copilot Spaces. Again, MCP heaven, but really important here to understand is, okay, we can configure all the MCPs in the world. That just means we have to set up our tools correctly. And if we don't set up our tools correctly, this is technically going to give, you might as well just use this standard agent, which again, for some use cases is what I continue to use. And in any case, you should be using the plan agent. And finally, the last primitive, let's say, is hooks. And I can show you quite a nice one, which I bring every project no matter what. It's non-optional. It's the security audit log. It happens before every tool use and after every tool use. And what does it do? It logs what happened. The script, super simple, like really badly written, generated. But the premise is easy. You log all tool invocations for the audit trail. You want to have some records, you want to write it to this folder. And now, okay, I deleted a lot of it, but you can see that this morning at some point, I wanted to generate the check the current, and I wanted to generate the greetings webinar attendees. And so I ran this, and you can see that that was, or even yesterday at this point. But yeah, you can see that it generates, says where it comes from, where it goes to, and yes, one of the more complex ones that I'm working on, and again, evolving stack, trying to give here how we set up it best for us, is the doc update trigger. So after every time a tool is called, we want to track what was done. And we want to then at the end, when the agent's done, we want to check if anything needs to be updated. And that track is basically just after every change, you parse and save it to here. And then at the end, actually, a pretty Frankenstein solution is to call the Copilot CLI with the prompt of information that changed and ask them if something needs to be changed, and if yes, what? And that gets injected back into the context. And from there, you can, generate your own documentation based on changes for a long-running agent. Again, long-running, the reason I'm not fully happy with it is because I believe that it shouldn't run after every tool change, and I'm trying to figure out when I would like it to run. Great. I'll use the next 4 minutes to show you what, again, a really Frankenstein way to do this, but I as I mentioned in the post, parallelizing this is possible. Not that it will give you the best results at all times, but I would say you kept, as I mentioned, you have prompts like this. You copy your prompt. We could also use it. It's just generate the instructions file. We want to use the best model possible. So we use the Opus 4.6. We want to unpin this if I can. Yes. And I want to paste this in. And so this prompt says here, really important. Okay. So it just says to what should we consider for the front end okay, what is the application identity? What's the context? What do we consider for the front end, the design system? What icons do we use? What library? These are common to all projects. So this can be really done in your setting where you build this prompt and have it a little bit better than what mine is. And you just say the rules. But what's a really important note here is that you instruct it to use sub-agents to research. Sub-agents are a feature of Copilot, a feature now of Cloud Code and all other solutions, more or less. And the idea is that you keep that context window clean. So you do the research with different agents, and then you bring it back, synthesize, and generate the documents. So I'm just going to let this run. Let's just make sure it starts. I don't have any issues. And then for the sake of, let's use infrastructure as well to show the parallelization. And let's see what we get here. Let's go away here. Let's add it. Again, similar thing. These instructions files can be centralized, located somewhere, and used then to generate these instructions based on the brownfield repo. If you keep an eye on the left-hand corner, you can actually see the status of what's happening with the agent, by the way. It just says what's required platform. So if it's Azure or whatever, the Terraform structure, the module preferences, what environments do we have? We need to find all this information out. Rules for input again, and then the same prompt at the end that we want to have it look in, for us, starting docs, but for a brownfield project, it would be infrastructure, right? It would be just pointed at a different area and do your research there. For now, we'll let it run as well. And we'll show you how it's working. So you can see here it spawned 3 sub-agents. It's reading the document separately. The current main agent is waiting, and we can do this to generate. This is not just for generating instructions. This is maybe a tip for, in general, using AI agents and what Florian will use in the end himself. Great. I can show you the same things exist for generating skills, for generating backend skills, for generating infrastructure skills, and for generating hooks. And given that the time, as I said, I'm pushing to get as much in as I can. Of course, I'm not living with the consequences of the things I just said if I don't show you that it's working, but yeah, you just got to believe me. But what I can do here given the time, is I can stop both of these and stop this one, and I can change to our main branch, force checkout. Let's say discard all 4-track files. And now you can see what actual infrastructure would look like in any case. So we have a code review agent, we have for front end, back end, whatever. If we go here, the great thing about agents is if we use a different instance. So let's say we don't want to use this, we want to use a CLI because, hey, I love CLIs and I want to use a TUI. We can actually see that because it's saved in the remote GitHub repo, we can actually use these agents here to do anything effectively. And if you see the SE security and the test specialist, they're actually from our company, Prodyna. We have a centralized location and where we store agents in which we're building for our workers. And so for companies, you can imagine that all of these things we created today, if they're super standard, like a backend agent, and you have a really specific stack, you can add backend Java agent. And then you have that for all of the people and you work together as a company to build out your stack of agents. Again, all of these instructions are used here. The MCP servers are used here. The skills are found. The agents are found. And again, the instructions are back-end, front-end, open API. We have a simple one. We have more prompts, but we have so many skills because skills in the end are, for example, design system. The design system skill encapsulates what we do, how we do it, and how the agent will develop front-end code. And so these are all just text files. And what I will say about this, because time, starting docs are irrelevant. This can be brownfield. This just, you need a source of information. 2, they're living documents. Update them, care for them, store them, have people review them. They're not a one and done. And the third thing is the agents, as you build them, are useful. You can select them, you can use them, but you can also put them in the cloud, have them review your code separately, and they become more powerful when they're not just working with you where you supervise them, but actually handing off tasks. I quickly jump back to the presentation. This is how we manage them, or how you can manage them. This is the most, let's say, suitable solution. The one we're trying currently is Agent Package Manager, APM. It's a Microsoft solution for managing the primitives. It works similar to how NPM is. You install it. There's a package similar to a package JSON. You have some form of modules that get used. The the agent package in this case has the most promise. It's actually a platform where you can have them, but it's worse than alpha. And I just like the idea. CanStack actually has an ability to use public skills. So you can sign in and take skills from there. And the GitHub.private is what you saw when I showed you that we have remote agents. So we store our remote agents for now in a GitHub private repo. You can search for how to do this. And from there, then you can see how you centralize your agents for your company so that not everyone has to keep writing the same agents and you end up with more standardization. Oof, my voice. Good. So I wanted to leave minutes at the end for questions, as I think I covered too much, but I wanted to give a good understanding of what Florian will be using next week. So Florian I will probably work on them more, right? I mean, we have to do some iterations, like I said, but Florian will use these primitives to build software next week. So it's not just, hey, in the end, it's easy. It's, we need to build these things and we think these will help. It is possible that newer models come and all of these things I just told you is lies. Hooks and skills are relatively new and they change the field, and this could be the case that instructions become less important. But that's what we'll find out along the way. But for now, we had last week's presentation, which you can see on YouTube right now if you scan the QR code. Next week's presentation is available here again on Livestorm. You can sign up. That will be a super interesting one because Florian takes all the risk, right? I mean, I basically showed you only how to configure it and what it looks like. Florian's going to have to use those, so I wish him well. But for now, that's all from what I have to say for today. Thanks. And this, yeah, I mean, we're Prodyna, of course. I do a random plug. Reach out. We can answer questions. These quick POCs to production, leveraging AI. This is the area we're focusing heavily on right now, and at least I am in my daily work. If you scan the QR code on the left, you'll get access to our website. Does anyone have any questions for me in the chat, or do I stare at a blank screen for the next minute and say goodbye? No, but I could ask if we can do this. As I said, it's not. We have a for this context. Thomas's question was, do you have this example repo with prompts, etc., available somewhere? For now, it's not open. I will talk with our colleagues internally, with Florian specifically, to see if we can do this, because it's a good idea, right? I mean, at least the structure of what we could do could provide some value. But in general, any project we do, we will now try to do this. So reach out and we can see. And I will bring it to Florian, and he will mention it next week in his presentation if it's possible. So I'll take that with me. Cool. If there's no more questions, I won't just look at the screen. I'll give everyone back 4 minutes of their day. This will be on YouTube at some point. I hope I don't become famous or something. But if you want to rewatch it or take screenshots of some of the files I showed, you should be able to get it on YouTube. This will be in the same place under the Prodina account, the same place you can find Martin's video from this week. I wish everyone a good rest of the day, evening, morning, depending. And yeah, I hope it was valuable for you, and you can join next week's session with Florian, where Florian takes the risk and hopefully delivers also a great presentation, like my colleague before me. Thanks, everyone, and have a nice afternoon.